back, everybody. My name is Dustin, and in the last video, we finished up with some of the physics bindings, and I left you guys with a small challenge to create the text component and the render text or RenderUI system. So in this video, we're going to quickly go over my implementation. First thing we're going to want to do is create the text component so we can get this render text to the screen. Now we already have our draw text in our render. Let's go to our render real fast. Rendering for render. So we already have this here, our draw text 2D, but this is a render function, like a render draw call. I don't want to do that. I want to be able to have a component with entities and we can control it with our ECS and our registry rather than having it with the render itself. These are more for debugging. We'll use these if necessary, more for placement and stuff like that nature. However, we're going to want to change it to have the component. So let's do that right now. Up here, ECS, components, add new component, our new H file, and it's going to be text component .h. We've done this before, nothing new, so we're going to need a couple includes. We're going to need sol for our bindings, and we're going to need to include the vertex rendering essentials vertex.h. Cool. We just want to include the vertex so we can get the color. Then we want to go namespace Scion for ECS, and we want to say struct text component. Okay. So what's the text component going to need? It needs to have a font, but we don't want to hold on to a pointer to the font. We're just going to hold on to the name of it and then grab the font from the asset manager. Okay. So we'll hold on to a string of s font name, and it will default to the pixel font that I've been using. And then we'll have the text string. What text is the text component? And this will just be an empty string by default. Okay, then it's going to have the padding, and that would just be 0 for now. Then it's going to have our wrap, so float wrap. If you remember the text bash renderer, we went over how we use the wrap. And then we're going to need the Scion rendering color. And that's just going to be the color, and it will default to white. Cool. And we want to have one flag for if it's hidden or not. Do we want to hide it? And it'll start off as not hidden. Cool. And we might as well do the bindings right now. So static void create Lua text bindings. Sol state reference Lua. Cool. All right, that's all we need for that. And let's just create this. Awesome. So the text component bindings are going to be straightforward. Since we've already done component bindings before, it will basically follow the same format. Now, let me know in the comments below if you were able to do this yourself. If not, no worries. We're going to do that right now. All right. So include entity. And we're going to say lua.new user type text component. For the name of this, we're going to actually have to call it text component because we already have a binding for the text. So if we go here and go to our scripting render bindings, I believe I already have one for text. Yes, right here. So we can't just call it text because we already have a binding for that. It basically has the same stuff, but that's being used for the render. Okay, so we want to have our text component, and it's going to be a little bit different. Basically the same idea, but this one we're going to have our meta bindings. So type ID ENTT type hash text component value. Cool. And now we want to have our constructor. So sol call constructor. And then we're going to want to have our factory. Sol factories. And that's just going to have const std string reference for the font name. Const std string reference for the text string. Then we're going to have our color. So Scion rendering color color, and then padding, and then the wrap. Cool. And we're going to want to just return a text component as font name is equal to font name. As text string is equal to as text string. Dot padding is equal to padding. Dot wrap is equal to wrap. And dot color is equal to color. And we'll just leave hidden as the default value. And now we just have to do our member variables. And that will just be the text string, text component, as text string, font name, text component, as font name, padding, padding, hidden. We want to be able to change these things in Lua, right? So you wrap. And for the last one is the color. Get rid of that. Oops. Color. Awesome. Okay, perfect. Now that we have the bindings completed for the text component, let's quickly go and add this into our scripting system. So I already have the scripting system here. So open it up, and then we want to add in our component. Text component. And then go down to where we're doing our, right here, and just register them. Cool. Awesome. So now that we have our text component bound, we can now start the RenderUI system. So that's what we're going to do right now. We're going to call it the RenderUI system, and we're going to have different ways to do this. Let's just go into our system. So render system, new, add. RenderUI system.h. Include the rendering core batch renderer. Just in case the UI has a sprite that we want to render, we want to have the batch renderer there. But we're not going to worry about rendering sprites at the moment. We're just going to care about text. So we need text batch renderer. Text batch renderer. And we're also going to need the camera. Okay. And then we're also going to include the registry. Cool. And then go namespace Scion4 systems. I believe that's what we called it. Let's open up a different system. Let's open up just render shape system. Yep. So systems. Matter of fact, we could probably just copy all of this. Yeah, let's just copy all of this. Copy. Change this to render UI. Change that. Change that. Here we want the specified registry. Registry. That will actually have the entities that we want, because this registry might just be the main registry. So we have to make sure that we actually have the right registry doing the work. And then here, change this to the sprite batch renderer, and change this to a text batch renderer. Change the name. Sprite text. Cool. And then, because this is UI, the UI system, it needs to have its own camera. So that's why we included the camera. So we're going to create a new camera. So std, unique pointer, Scion, rendering, camera 2D. Why does it need its own camera? Because we don't want it to move. Like if it's UI, we need it to be screen space only and never move. We don't want it to move as the world moves, so it needs its own camera. Okay, so let's create these. And create. Awesome. Let's go into our RenderUISystem.cpp. And let's just quickly change this. So let's do our initializing. So it's our registry. Takes in the registry. The sprite batch or sprite render is equal to std make unique. And the text batch the same. All right, and our camera, we'll just start it here as null pointer. And we'll do our initializing right here. So np camera2d is equal to std make unique Scion rendering camera2d. And we're just going to do 640, 480 to start. Now that's going to have to change. It's going to have to be based on the current window, but we'll look into that later. We'll get to that. So MP camera2D, and we just want to update it one time right here. So it does its initial update, and then we don't need to update it again because it won't be changing, okay? All right, and up here we need to do a few includes. So let's go include, and let's go ECS, and components, and let's get our text component, and then our transform component. Okay, then we're also going to need our asset manager, resources, asset manager, and our logger. Using namespace Scion for ECF and Scion resources. Cool. All right, now the meat and potatoes is the update function. So the first thing we're going to want to do is actually get the font shader. If it doesn't have a font shader, just leave the function. There's no need to even try. Okay, so let's go auto reference asset manager is equal to the M registry get context std shared pointer asset manager. Now, if you want with the registry, since we have a registry bindings and the context, we can, instead of saying get context, we can make a wrapper function around this because we know we're going to have the asset manager when we first build the registry. We know we're going to have certain things. You can actually make functions that do that for you, right? So instead of just saying get context and adding it in, just have one that says get asset manager, get this, get that, and add those functions in if you like. It'll make it easier and a bit cleaner. Or you can just continue using this as I am doing now, okay? So now we want to get our font shader. So autumn p font shader is equal to asset manager get font and oh no, sorry, not get font, get shader. Get shader, and that's the font shader. I believe that's what we called it. So we're going to want to check to see if the font shader is null pointer. So if not p font shader, we're just going to want to return here and have a slight error. So Scion error failed to get the font shader from the asset manager. Cool, and then it'll just leave the function. And now we want to get our camera matrix. So auto cam mat is equal to mp camera2d get camera matrix. And then our view, so auto view, and we'll say text view is equal to the registry that we're sending in as an argument, registry.view. And we want it to have a text component, and it has to have a transform component. Okay. And then we need to enable our font shader and then set our uniform. P font shader, set uniform mat 4. Now I don't remember the name of it, so we're gonna have to go check that and then see KM mat. So let's quickly go to our shader here, and our shaders right now are, everything right now is in our editor, but that won't be the case forever. Eventually we're gonna have a runtime project, but we'll get into that later. We're actually quite far away from that. So not fonts. My brain's on fonts for some reason. Shaders, and the font shader.vert right here, and it's called view projection. Okay, cool. So let's go back into our RenderUI system, view projection for camera matrix. Awesome. Now that we have that, we can begin our text batch. Text batch render. So begin. And now let's loop through all of our entities that have a text component. Okay. So for auto, entity, in text view. We need to do some stuff in here. All right. So the first thing we're going to want to do is actually get the text component just as a const auto reference text. And we can just say text view dot get text component of this entity. Okay. We need to see if the font name is empty or the text is hidden. Because if it is, we're just going to continue. We're going to go to the next entity. So if text.sFontName is empty or text is hidden, just continue, because it doesn't have a font and it's hidden. So we don't want to try to render it. Okay. So now let's get the font. Const auto reference p font is equal to asset manager get font. Actually, I don't know if this needs to be a reference, but we'll send it as a reference. And get the font as from the font name. And if not p font, we just want to continue. But we can also add an error here if we like. So we can go Scion error font name does not exist. Text.sFont. Oh, not font. Just font with the name does not exist in the asset manager. Cool. So now if we got here, we want to get our transform component. So I go const auto reference transform is equal to text view dot get transform component of the entity. Cool. And here's where we want to do all of our model transforms. Okay, so let's go to our render system, because we're already doing it there. Or render shape system should already be there. And right here, and let's just copy all of this and go to our RenderUI system and paste that in. And we're going to need to get rid of the box collider.width. Instead of box collider.width, we actually want to get the p font. Okay, so we have to include font. So is it p font? Yep, get font returns a shared pointer to a font. Up here, it's not seeing any of the functions. So let's include rendering essentials font. And let's say p font. All right, I don't remember what the name of the function is. So we have to go there. Rendering essentials font, and I want get font size. And let's go back. Cool. Now if we have to change this, we will. But let's try it and see. So right now I'm just assuming the size is whatever the font size is. Cool. And now that we have our model here, we're going to want to np text batch renderer, add text, And that takes the text. So we need to go text.textstring, takes in the font. So just p font. Takes in the position. So that's transform.position. Takes in the padding. So text.padding. The wrap, text.wrap. The color, text.color. Model. Cool. That's happy. All right. Yes, it does have the model. Awesome. That's exactly what I want. All right. Then after we do that, all we have to do is go MP text render and then render. And then disable our font shader. Font shader, disable, not enable, disable. Cool. All right, and that's it. Let's do a quick build to see if that works for us. Awesome, no errors. Now we're not going to see anything because we didn't add anything yet. We're not erroring out. Let's go and quickly add this into our application and put it into our registry. So here, let's go back to our editor. Move this. Source, application. So it's another render system. So with our other render systems, render just UI now. And we can go to wherever we're adding in our render system. Render system, all of this, copy this. Cool. Render UI. Change this to render UI. Add to contents. Render UI. Render UI. Be able to create the RenderUI system. Be able to add the render system. Cool. That should be perfect for us. That's all we're doing here, just adding in, just like we've done with everything, to our registry context. Now let's go back down to our render function. Down here, and we'll grab the RenderUI system. RenderUI. Now we are just assuming that it's there. We're not checking to see. You may want to put checks in, but we did add it in, so it should be there. Okay. And we're going to render the UI on top of everything. So we're going to do that here. Update. And we're going to send in the registry. Except for this, these draw line, these are the renderer. You don't really need these, but these are good for debugging. So we'll just leave that out there. So update, we need to take our registry. So MP registry, get registry. Cool. Even though it is using the same registry, it may not, because later on when we're starting to actually run scenes in the editor, it will have a separate registry. Okay. So that's why I'm trying to separate them now. And we'll get into that more later. And this should build, so let's just run it. We still won't see any text, but we can build it right now. Cool, built, no issues. Close it. Let's go to our main.lua. So that would be in our editor. Open up our assets. And then we have our script, main.lua. So we have a lot of stuff from the last time that we did this. So I've got some stuff I want to try to do, but we'll get into that shortly. Let's add in a few different things. So down here, right before our functions, okay, right here, let's create a couple variables. So we'll go local, ball, count. That'll be just 0. Then we'll say local, count, entity, count, ent, equal to entity, just an empty entity. And then we're going to add count, and add component. And we're going to want to have a transform. And we're going to put this at vec2, 10, and 32. Vec2, 1 and 1 for scale. And no rotation. Cool. We'll add another component to the count n. This needs to be a capital T. And this is going to be our text component. Text component. Let's get rid of everything inside. And we'll say, so let's say pixel for font. I'm going to start it at 0 because this is going to be our count. And then the color. Wait, no. let's not start at 0. Let's have this be the label. So we'll just say ball count. So we'll change that, yeah. Label, and no, we'll just keep it as count. And we'll send in our color. Just gonna be 255, 255, 255, 255. Padding 4 minus 1 dot 0 for the wrap. Cool. So there's our count int. Let's copy this and make another one that will actually have the value. Okay, so it's more like a label. You can change that if you like. And we'll just change this to val int. Val. Val. And then this one needs to be beyond the ball count. Now we don't have a measure text function yet, so we're gonna have to add that in later. But right now we can just move this to, I think it's 352. Everything else can be the same. We'll just keep this here and change this to 0. But we want to return the local, and we'll say val text. I want to have a reference to that because we're going to use it below. So we have our ball count and we have our val text. Let's just run this real fast and see if these show up on the screen. And we got some errors, which is great. Simple ones, 144, so we're expecting a bracket, or 114. So 114 here. So we're expecting another one here. Run it again. Okay, 119. Yeah, same problem. Run it again. 112. No matching takes function color. Did we not do? Oh, silly me. That was my issue. Sorry, guys. Here, take away these and try again. All right. Maybe it does need that still. 112. Silly me again. I needed that comma there, but on this side of it. Cool. That should run now. I think we did fix all the mistakes. Awesome. So we have our ball count, which is 0. And it's on top, as you see, it's on top of everything, but it's not counting everything yet. So let's go here. And every time we create a ball down here, let's go ball count is equal to ball count plus 1. And then down here, we need to update that. We need to update our text, and we have our val text is equal to toString ball count. All right. Oh, still not going up. Did I add that to the right place? Create ball count plus 1. Oh, surprised that didn't give me an error. Val text dot, what do we call that? Text string? Text string. Yeah, that should have given me an error. All right, let's try again. There we go. So our count's going up. We have our UI system rendering. Perfect. That's exactly what I want. Now, I was going to do some other stuff for this video, but this video is already taking a bit long. But in the next video, we'll quickly go over that. I'll make another short video, probably tomorrow. So let's say we're doing this, and I start rendering outside of the window. Like, it's not going to work the way we want. So say we move the camera, and the camera's moving with our ball, and it's going that way. But right now, we're just getting the screen position. So anywhere I click on the screen, we won't see it because the camera would have moved. So we need to actually change how we're getting our position for the mouse. So instead of just having the screen position, because that's what we have right now, we're going to want to add in the world position. So we're going to need to add some functions to the camera and the camera 2D. And we're also going to make a little follow camera, but we're going to do that in Lua. So the camera will follow the ball, and we'll do that in the next video. I'll make another quick video tomorrow on how to do that. Actually, if you want, try to make the follow cam on your own. So it's in Lua. So all you would have to do is create a new file. That could be a little challenge for you. Create a new file and just right here and anywhere, right? And load it in with our run script function. So make a new file, call it follow cam or camera follow system or something like that, whatever you like. and have it where the camera will move based on the position of the ball. Give it some limits, some window limits, so the camera will stop based on a limit, and have it follow the camera and have the ball in the center. So the camera will move with the ball. All right, so that's a little challenge for you. And we'll just use the main camera. So we can grab the main camera, right? So up here in our system, or not in our systems, in our bindings, we have our render bindings. We have access to the camera. So just grab the camera so you can get an instance of it, give it to the follow camera, and set its position based on the player position and have it follow, but do it in Lua. That's the goal. So try to do it in Lua. If not, if you can do that, awesome. Try it and post it in the comments. If not, we're going to go over it in the next video. Okay, take it easy.